Here's some homework help for the lesson 7-2 assignment. I've chosen 3 problems from this page 479 and 480. Let's get started with my pen to write here. First of all, we need to, in order to subtract these two fractions, they have to have the same denominator. And so we're going to find the least common denominator. And that starts with factoring. So let me show you in red the factored form of these denominators. So we can do 2x times x, and then we'll have the factors of -6 being used on these. So we can do +6 and -1. So just a quick FOIL check. 2x squared plus 12x minus 1x minus 6. That checks out. All right, and then over here, we'll use the factors of -18 that add up to +3, and that is x plus 6, x minus 3. Okay, now that we've got the factored form of the denominators, we're now ready to come up with our least common denominator, and that's really just a combination of these factors, but common factors only need to be written once. So my green will represent the LCD, 2x minus 1, x plus 6, x minus 3. And I'm going to put that for each fraction. We're basically going to turn these red fractions into equivalent fractions using this particular denominator for both so that we can actually subtract them. All right, so the process of making these equivalent fractions involves division. We're going to divide the red into the green, the factored form of the original problem, into the LCD. And if you'll notice, everything cancels except for x minus 3. And x minus 3 will be multiplied by 6. And when I do that, I get 6x minus 18. Over here, everything cancels. If I divide red into green, I'm left with 2x minus 1. And 2x minus 1 times 8 is 16x minus 8. Now I'm ready to put these numerators together, combine like terms, all over our common denominator. Okay, so 6x minus 16x is -10x. And -18 minus -8, remember, you got to be careful with subtraction. You're subtracting both of these terms, and subtracting a negative really means to add. So -18 plus 8 is -10. I want you to look for opportunities to factor. Even if it doesn't result in being able to cancel, it's a good practice to get into, because if you don't, you may miss an opportunity to reduce, and that could cost you points on a test. So I can factor out -10 multiplied times x plus 1 all over the LCD 2x minus 1, x plus 6, x minus 3, and that ends up being our final answer for number 31. All right, let's try another one, number 32. This time we're going to be adding, but the process is very similar. We still need to get the factored form of these denominators so that it makes it easier to find the LCD. All right, so factoring this left denominator as two linear binomials, we can do 4x times x. And by the way, if you need to use the box method, I'm just kind of jumping right into it, but if you're not seeing visually how to come up with the factoring, you're always welcome to do the box method. And in some cases, that's what you're going to have to do to get this right. Okay, so a quick FOIL check. 4x squared plus 8 plus 1 is 9, plus 2. That looks good. All right, let's go over here, and I notice there's a GCF over here, so let's factor out the 2 first, and then see what remains. The x squared minus 4x minus 12. And now we'll just work on factoring this. The factors of negative 8 and negative 12 that add up to negative 4. We could do negative 6 and positive 2. Okay, so just put this over here. And we're going to replace it with the factored form. So we will have x minus 6, x plus 2. X squared plus 2 minus 6 is minus 4. Alright, so we're good. Okay, now it makes it easy to see what the LCD should be. And so we gather up these factors. Have 4x plus 1. I have x plus 2 is a common factor, just need to write it once. X minus 6. Then I've got this number 2, I'll just put it out here in front. So this represents, this whole long expression, factored polynomial represents the LCD. Alright, now let's do our division process. So you can think of it this way, just look at what doesn't cancel. What doesn't cancel when you compare red to green will be x minus 6 and 2. Alright, and if we put that together, it would be 2x minus 12. And that needs to multiply by 2x. Okay, did you catch that? 2 times x minus 6, and now multiply that times 2x. And that gives us 4x squared minus 24x. Alright, now let's jump over here and just pay attention to what doesn't cancel. And everything cancels except for 4x plus 1 when you compare red to green. So 4x plus 1 is going to multiply by 3. So that would be 12x plus 3. Okay, now we're ready to put these two together now that we have a common denominator. X plus 2, x minus 6, and you can combine like terms. There's only one quadratic term. We do have a couple of linear terms. When we put those together, that's minus 12x, and then plus 3. Don't see any way to factor the numerator. So that ends up being our final answer for number 32. Okay, one more, and this is from the complex fraction section. This is number 39, as you can see. And we need to get the LCD for both halves of this complex fraction. And fortunately, you're going to see that the LCD is going to be the same for both parts. And that makes simplifying these really pretty nice. So let's just go into our normal routine. You can see the LCD for this top half of the complex fraction is x minus 9 times 3x plus 2. So I'll just put that down twice, and we'll do our division multiplication process. Almost ran out of room, but you can see what that is. Okay, so let's just go ahead and take care of this top half. If I divide x minus 9 into this LCD, the x minus 9s would cancel. And the part that doesn't cancel, 3x plus 2, multiplies by 8. And that will be 24x plus 16. Same idea over here. This time 3x plus 2 is going to cancel, leaving x minus 9. And I'm going to multiply x minus 9 times x. That's x squared minus 9x. Alright, down here, and I've already mentioned that we have the same LCD. This time we're going to be adding. Up here we were subtracting, so same LCD, 3x plus 2, x minus 9, 3x plus 2, x minus 9. And when I divide 3x plus 2 in the LCD, the 3x plus 2's would cancel. And so you can always remember the part that doesn't cancel multiplies. And that would be 3x minus 27. Alright, this time x minus 9 will cancel, and so we'll multiply 3x plus 2 times 4x. That's 12x squared plus 8x. We are now ready to put these two different fractions being subtracted, being added, put those together into single fractions. So let's take the top part of the complex fraction, and when we put those together, combining like terms in the numerator, we would have, I'll change color here, we'll have negative x squared, and then we have 24 minus negative 9. Remember, be careful here, common mistake. 24 minus negative 9 is 33x, plus 33x, and then plus 16. Over the LCD. Okay, and the bottom half of our complex fraction, we'll do the same thing, combine the numerators. We'll have 12x squared, and then 3x plus 8x is 11x, and then minus 27 over that same LCD. Okay, well, I talked in the notes in the class earlier that whenever the LCD is the same between these two halves of the complex fraction, you can really think of it this way. These denominators will cancel each other. And what is left will be our answer, which is really going to be the two numerators. And so my final answer is going to be negative x squared plus 33x plus 16 over this other numerator from the bottom part of the complex fraction, 12x squared plus 11x minus 27. And there you have it. So pretty easy, pretty nice when the LCDs are the same in both from the top and the bottom, comparing the top half of the complex fraction to the bottom half. All right, I hope that helps you with the rest of the problems in this assignment. If you have any questions, let me know.